Alright, here's a gas problem from Alex. We're going to take some heptane and we're going to burn that to produce carbon dioxide and water. Alright, so those are the reactions we're going to be worried about, and it's asking us, let's first write the balanced equation. Well, let's do that, and then given a certain mass of heptane and certain conditions such as 1 atmosphere and the temperature at 10 degrees C, calculate the volume of carbon dioxide that is produced. Alright, so we're going to have to use our ideal gas law. You can see that is PV equals nRT. And since it's asking for volume, let's just go ahead and solve. That volume equals nRT divided by exactly 1 atmosphere, so that won't figure into our sig figs. Okay, let's write that balanced equation first. So I have C7H16, and if I say combustion, you should know right away that it is going to be oxygen that is going to react with, and that is going to give us CO2 plus H2O. When I balance combustion problems, I always look at the hydrogens first. So I have 16 on this side, so I put it 8 right there. That'll give me 16. Finally, if I go to the carbons, there's 7, so that'll give me 14 and 8, 22. That'll be 11 oxygens. So this should balance it for us right here. Okay, let's think about that stoichiometry. So I have 0.470 kilograms of the C7H16. Well, I know I got to deal in moles, and so let's get to grams. So I know that in 1 kilogram there are 1,000 grams of C7H16. And I know from looking at my periodic table and doing some quick math, that's 84 and 16, that's going to be 100 grams in 1 mole of C7H16. Now that I'm in moles, I can do my stoichiometry. I know that for every 1 mole of the C7H16, I make 7 moles of CO2. So that's 1 mole of C7H16. It's going to produce 7 moles of CO2. All right, units cancel. Are each of these true statements? I believe that they are. All right, so we can quickly do this math. And so I have here 0.470 times 1,000 divided by 100 times 7. If I do that, that gives me 32.9 moles of CO2. Okay, so I can take this number of moles and put it in here because it's asking about CO2. All right, I know what R is. It is 0.08206, and it's going to have units of degrees Kelvin and moles and atmospheres and liters. Okay, so I need to make sure I am in all of those. I am in atmospheres, so that's good. And 10 degrees C, that needs to be converted to kelvins. So let's go 10.0 plus 273.15. That's going to give me 283.15. My sig figs are coming down right there. So I have 4 sig figs, and I have 3 sig figs right here. And so 3 sig figs should be in my answer. All right, so let's just substitute things in. Volume equals the number of moles, which is 32.9, times R, which is 0.08206, times the temperature in degrees Kelvin, 283.15. So let's do that real quick. 32.9 times 0.08206 times 283.15, and that gives me 764.4. So I have 764.4, and so with sig figs of being 3, that would be 764 liters. And there is my answer. So actually not too bad, right? Write the balanced equation first. Then do the stoichiometry to get the moles of CO2. Moles will then be substituted into our ideal gas law. Everything else is given. Make sure we get it into the right units. And then we can just do some basic math. These aren't as hard as they appear at first. Just have to kind of know what we're doing. Hopefully this video helps you.